concept to increase the fleet's seeking and striking capability. In-flight fueling of carrier aircraft. The sustaining tanker concept increases the operational flexibility of carrier-based aircraft. Refueling is accomplished by making contact with a tanker aircraft near the carrier task force. The strike tanker concept is used to increase the combat radius of attack aircraft. Two compatible airplanes fly a buddy mission. The tanker and strike airplane fly in formation to a point approximately half the distance to the target. The attack aircraft's fuel tanks are refilled, and thus its combat radius is increased. The tanker returns to its carrier, while the attack airplane continues on its mission. The advantages of these systems are obvious. The in-flight fueling store makes them immediately available for use with current carrier aircraft, propeller-powered AD-6s and 7s, jet-powered A-4Ds, and with other aircraft equipped to carry external stores. In-flight fueling must be immediately available whenever the Navy considers it an operational advantage. The Douglas in-flight fueling store accomplishes this objective simply and efficiently. This external store converts a piston-engined Navy attack airplane to a tanker within minutes. The store contains a large quantity of jet fuel. It is connected to an isolated tanker fuel system. These specially designed wing tanks supplement the store's supply. A jet-engined Navy attack airplane can be converted in even less time. By becoming an integral part of the tanker airplane's jet fuel system, the store permits the tanker to transfer all fuel in excess of that required for its return to its carrier. Reconversion to combat configuration is just as simple. Standard suspension lugs attached to the airplane's bomb rack. This electrical line and fuel flow and air pressure lines are the only connections necessary. This ram air turbine, driven by the wind stream, is the primary source of power for the hydraulically driven fuel pump and drogue hose reel. The turbine blades automatically adjust pitch to maintain constant propeller speed and feather when the power unit is not in use. This large port offers easy access for ground servicing. The store is 17 feet long and has a maximum diameter of 31 inches. Fully loaded with fuel, it weighs 2,700 pounds. The rear section contains the demountable hose reel unit, the drogue extending mechanism with its ejection spring, and the drogue itself. The radial forces resulting from the slipstream cause the drogue to blossom to its full diameter immediately following ejection and to draw out to the end of its hose. Inside the cockpit, a simple console gives the tanker pilot complete control over the external store. He activates the store's systems with this master switch. He controls the quantity of fuel transferred. He may return fuel from the external store tanks to his airplane's tanks. He may dump fuel from the store. His normal bomb release permits him to jettison the store in an emergency. Here's a typical strike tanker mission being readied. The A-4D's fuel tanks are being filled. The in-flight fueling store may be filled by a normal gravity system, as here, or by a high-flow pressure fueling system. The hydraulic fluid level is now being checked. Other items which may be checked periodically through easily accessible ports are the hose reel mechanism, the electrical system, and the hydraulic and fuel connections. The pilot of the attack aircraft on the buddy strike mission gets into his cockpit. The strike tanker takes off. The attack airplane follows immediately. The two aircraft fly at high speed in close formation to the point of refueling. The tanker pilot tells the receiver that it is time for the attack airplane to refuel. The attack airplane takes its position slightly behind and below the tanker. The tanker pilot turns on the in-flight fueling store's master switch. The turbine spins in the wind stream, powering the store's hydraulic systems. This indicator will show the drogue position at all times, including its readiness for effecting fuel transfer. This one will show the total amount of fuel transferred. When the aircraft are ready to transfer fuel, the tanker pilot ejects the drogue and switches to transfer, so that fuel transfer will start automatically when the receiver's probe has engaged the drogue. The drogue blossoms immediately, automatically unwinding its 2-inch hose to full trail position. The amber light on the store tail cone signals that the drogue is ready for hookup. The pilot of the receiver aircraft moves up to the engaging position. He moves forward and engages. When the amber light goes off, the receiver pilot knows that the engagement is completed. The green light signals that the flow of fuel has begun. It is transferred at a high rate. Engagements can be effectively and safely made at speed differentials of from 1 to 10 knots. A hose tensioning system prevents hose whip, whatever the speed or altitude. The two aircraft, compatible in performance, continue toward the target at normal cruising speed and altitude. Fuel transfer is completed within a few minutes. The green light goes out, indicating to the receiver pilot that transfer has been completed. He disengages from the drogue. He continues on his mission with fuel tanks filled to capacity. The tanker aircraft returns to its carrier. The Douglas in-flight fueling store is now in volume production, ready to serve the new fleet concept, in-flight fueling of carrier aircraft to increase the fleet's seeking and striking capability.